Okay, so the place I wanted to start off with today is making sure everybody is speaking the same language in a couple of aspects. One, with our units of measurement, and then with some of our conversion processes and Roman numerals and stuff like that. So we talk about measurement. Oops, my pen is acting really funny here today, but that's okay. What I grew up calling the standard system of measurement, of course, is no longer the standard system of measurement. There's the U.S. customary. Like I said, that's the one that I grew up calling the standard measurement system. And now, of course, it's the metric standard system. And to deal with metric units, all you really have to do is understand the prefixes. For medicine, a lot of the prefixes are not used, but we start out with our main unit. And of course, for volume, that is the liter. For mass, it's the gram. For length, it would be a meter. And those are really the three main units that are used for everything. Going smaller, they add a prefix. So the prefix deci means 1/10. And so the abbreviation DL, DG, or DM, oops, don't know what happened there, stands for deciliter, decigram, decimeter. It's 1/10 of a liter, 1/10 of a gram, and so on. By the way, you always see me capitalize the L for liter because I was told at a young age that I had to capitalize the L. Found out later that wasn't necessarily true. It was just, if you have something like this, I'm trying to decide, is that 5 liters or 51? Well, if you use a capital L for liters, it just avoids that. So you'll see me use a capital L, but that doesn't mean it has to be done that way. It's just old habits. Continuing to go smaller, centi. Think of years in a century or cents in a dollar. It's 1/100th. So centiliter, centigram, centimeter is 100th of one of those units. And milli, if you pay property taxes, a mill is 1,000th. 1,000. Milli is 1,000th. So milliliter, milligram, millimeter is 1,000th of the main unit. And then we skip over the 10,000 and 100,000. And we go to the millionth, which is micro. And here's where the abbreviation gets a little confusing. The official abbreviation for micro is that Greek letter mu. It looks kind of like a P with an open top to it. So you could see the abbreviation milliliter, milligram, millimeter, meaning a millionth of each of those units. Or in fields, and the medical field is one of them, where you have to keyboard a lot of information into the computer. Well, that symbol isn't a standard key on the keyboard, so some fields tend to use MCL for microliter, MCG for microgram, and MCM for micrometer, just so that they don't have to go through the process of copying and pasting that Greek letter mu into whatever they're keyboarding in. Going larger, of course, deca is 10. We tend not to use that one. Hecto is 100. The one we tend to use most, kilo, which is 1,000. So kiloliter, kilogram, kilometer is 1,000. And then again, we skip 10,000 and 100,000, and we go up to a million, which is mega. And you'll notice I spelt mega with a capital M when we abbreviate it. Of course, mega means million. We use the capital M. So capital ML is a megaliter, capital MG is a megagram, capital M, little m is a megameter. A megagram, by the way, is if you ever hear on the news, they say a metric ton. That's what they're talking about. It's 1,000,000 grams or 1,000 kilograms is a megagram or a metric ton. The conversions on these are pretty simple. You just move the decimal points. If I have, come here. Sorry, my computer's not behaving real well today either. So if I
started something.
What's that?
I said, sorry, I might have started something.
No, my computer's old. It's pushing 5 years old right now. In fact, tomorrow morning it goes away, and I'm a little sad because I have never had a replacement computer that went smoothly. Mm-hmm. It usually takes a few weeks before it works correctly once I get it. So I'm not going to complain about this one too much. So if we want to convert if we have 0.18 milligrams and we want to convert to micrograms, we go to our chart. Here is milligrams. Here is micrograms. On the chart, that's 3 spots to the right. So one way we could do that conversion is to just move our decimal point 3 spots to the right. We have to add a 0 for the third spot. That's 180 micrograms. We like to use dimensional analysis for medical math, so we also could have done 0.18 milligrams and then done a conversion factor. We know that 1 milligram equals 1,000 micrograms. The micrograms cancel out in this, and we'd multiply 0.18 times 1,000 is 180. We have the microgram units up top. And on bottom, 1 times 1 is 1. This process I just did is called dimensional analysis. And I kind of jumped into it quickly there, so let's go back and talk about what I did and why. So I started out with my original measurement, the 0.18 milligrams. I make it a fraction by putting it over 1. Simplest way to make anything into a fraction, just put it over 1 as a denominator. Now I want to use a conversion factor, and the conversion factor is just what we call a unity fraction. And a unity fraction is simply any fraction where the numerator is equal to the denominator. Now you look at it, 1,001 doesn't look like they're equal, but you have to look at the units. 1,000 micrograms is equivalent to 1 milligram. So yes, the numerator and denominator are equal. So that means when we multiply by it, it does not change the value. It'll simply change the appearance. And so how do we know what to put in that unity fraction? Well, it comes down to the units that we're trying to get rid of and the units we're trying to convert to. We're trying to get rid of milligrams. And since milligrams are on top, we put milligrams on bottom so that they will cross-cancel in our fraction. So the milligrams cancel out. The other unit we want to use in our unity fraction is the units we're changing to, which is the micrograms. So that's why I put micrograms on top. And we put the appropriate numbers. 1,000 micrograms equals 1 milligram. So the 0.18 times 1,000 micrograms gives us the 180 micrograms. Let's do another quick conversion. Let's say I have 3,100 grams. And I want to convert to kilograms. So again, I can go up here and find, here is my grams. Here's kilograms. That's 1, 2, 3 spots to the left on the chart. So the easiest way to make that conversion is to move my decimal point the same number of spots, 3 spots to the left. There is no decimal written in the number 3,100. So it goes at the end of the number. I move it 3 spots to the left. 1, 2, 3. It ends up as 3.1 kilograms. Or the other option, again, to use the dimensional analysis. I have my 3,100 grams over 1. Again, I'm trying to get rid of grams, so I'm going to put grams on bottom. I'm converting grams into kilograms, so I'm going to put kilograms on top. And I know that 1 kilogram is 1,000 grams. And so now the grams will cancel out. On top, I have 3,100 times 1 kilogram. 3,100 kilograms. And on bottom, I have 1 times 1,000, which is 1,000. So in the previous example, the bottom just multiplied up to 1, so dividing by 1 doesn't change anything. Here, the bottom multiplies up to something significant. It's bigger than 1, so we do have to divide that out. 3,100 divided by 1,000 is 3.1 kilograms. So we get to the same answer either way. One of the reasons I show you the multiple ways of converting is in math, we're so used to being told there's only one right way to do things. That's absolutely not true. There's only one correct answer, but in most cases, there are several processes that will get us to that correct answer. And so that's one of the things I'm going to show you later on is I'm going to show you for our dosage calculations 3 different methods. Now I'm going to have a preference for my favorite method, but I will give you examples for all 3. So since we're dealing with measurement conversions here, not only do we have to convert within the metric system, but we do still have all those US customary units mixed in with things. So we need to be able to do those conversions between the customary and the metric. And probably the most common equivalency that you will need is to know that 1 kilogram is 2.2 pounds. More and more of our medications are going to be dosed based per kilogram rather than pounds as time moves on. So that conversion is very important. If I know that a patient comes in at 120 pounds, and I need to know what that is in kilograms for dosage, well, I'll do my dimensional analysis. I'll put my 120 pounds over 1. I need to get rid of pounds, so I'm going to put pounds on bottom so that they'll cancel out. Kilograms on top. 1 kilogram is 2.2 pounds. Pounds cancel out. On top, 120 times a kilogram is 120 kilograms. On bottom, 1 times 2.2 is 2.2. And we'll divide it out. Gives us 54.5 pounds or kilograms about. Another common conversion, 1 inch equals 2.54 centimeters. So if we were looking at someone who comes in who says they are 5'10", well, first thing we would have to do is be able to put this all completely into inches. And so we separate out, you treat it almost like a fraction, a mixed number going into an improper fraction. We take the 5 times 12 to make it into inches. That's 60 inches. Plus the 10 inches gives us 70 inches of total height. If we need to convert that into centimeters, then I'm going to write out the unit inch, put 70 inches over 1. Now again, inches are on top and we're trying to get rid of it, so I'm going to put inches on bottom. And we're converting to centimeters, so put centimeters on top. 1 inch is 2.54 centimeters. The inches cross cancel out, and on top we have 70 times 2.54. Give us 177.8 centimeters. And on bottom, 1 times 1 is just 1, so that doesn't change anything. So that patient that's 5'10" is 177.8 centimeters tall. As far as the medical side of it, we have 1 teaspoon equals 5 milliliters. So if you have something, an older medication or an older reference book that says to give 3 teaspoons, and we need to convert that into milliliters, again, we'll set it up with the dimensional analysis. Put the 3 teaspoons over 1. We'll put teaspoons on bottom so they cancel out. 1 teaspoon is 5 milliliters. Teaspoon cancels out, and on top, 3 times 5 milliliters is 15 milliliters. And on bottom, 1 times 1 is 1, so that's just 15 milliliters. Anybody want more practice with converting units? Okay. So then the next conversion, oops, go ahead.
No.
Okay. So the next conversion is temperature. So we have our degrees Fahrenheit, and I'm just going to put degrees F because I don't feel like trying to remember how to spell Fahrenheit right now, and degrees Celsius. Our benchmarks for temperature, of course, are water freezing and water boiling. And of course, in the Fahrenheit temperature scale, water freezes at 32 degrees Fahrenheit and boils 212 degrees Fahrenheit. In the Celsius scale, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius, which causes some issues because unlike all of our other units, there's no common 0 point. For all of our other units, 0 meters equals 0 inches, 0 pounds equals 0 kilograms, 0 teaspoons equals 0 milliliters. Every other unit, 0 is 0, except for temperature. So because there's no common 0 point, temperature is the one thing we cannot convert with dimensional analysis. We have to use formulas. So if we're converting from Fahrenheit to Celsius, we have the formula that the Celsius temperature is equal to 5/9 times Fahrenheit minus 32. So this minus 32 is just accounting for that difference in 0 point. So human body temperature, of course, 98.6 degrees Fahrenheit. Actually, research is showing that that's not quite right, but that's what we still use. So if I want to convert that into degrees Celsius, I put it in for F. Oops, I won't put the degrees on it. And we do our order of operations. So order of operations says parentheses first. 98.6 minus 32 is 66.6. And 5/9 times 66.6 should give us 37, and it does. So human body temperature, 37 degrees Celsius. If I want to go the other way from Celsius to Fahrenheit, we just reverse that formula. Our Fahrenheit temperature is equal to our Celsius temperature times 9/5, or 9/5 times the Celsius temperature. Then we add 32 to the end of that. So let's say that on the way into school today, you heard the weather announcer say that it's going to be 11 degrees Celsius today. What does that mean? Well, we come over here and we replace the Celsius, the C, with 11. And if we multiply that out, 9/5 times 11 plus 32, we get 51.8 degrees. So that 11 degrees Celsius day is 51.8 degrees Fahrenheit. Not too far off from what it's actually going to be. So the final unit I want to talk about before we get into the actual conversion, the calculations, I want to talk about well, 1 grains, and then a little bit of basic Roman numerals. So grains actually originated as part of the customary measuring system. 1 pound is equivalent to 7,000 grains. But because grains were so ingrained, pardon the pun, in the medical fields, it was kind of absorbed into the metric system and not absorbed very well. In the metric system, now depending on what textbook you look at, 1 gram is 15 grains, and 1 grain is 60 milligrams. You might notice there, if I do 15 times 60, I get 900 milligrams in a gram, and we all know it's supposed to be 1,000. That's because technically, this is like 65.4, and this is technically 15.3 or 4, somewhere in there. In fact, some textbooks actually do use 65 milligrams in a grain instead of 60 milligrams in a grain. Which one do you guys use, by the way? Do you guys use 60, if I remember right, don't you?
We use 60, yes.
Okay. So that's the one I'll use in all my examples. Just be aware it's a little bit off when you use it. It's a little bit of a sloppy conversion. Then basic Roman numerals. The Greek letter I, of course, corresponds to 1. V corresponds to 5. And X corresponds to 10. And then the one that's a little bit less common, SS, is 1/2. Outside of those, you shouldn't need to know any of the larger symbols. You do need to know the difference between subtractive notation and additive notation. If it's a larger symbol followed by a smaller symbol, that's standard or additive notation. That's just going to be 5 plus 1 equals 6. If it's a smaller symbol followed by a larger symbol, like IV, 1 before 5 means it's a subtraction. It's 5 minus 1, or 4. So if we have an order that calls for GRIV, when you're dealing with grains, it's very common to use this reverse notation where you put the unit before the amount, before the number. IV, of course, is 4, so that's saying 4 grains. And if we need to convert that into milligrams for our dosage, again, we can go to our dimensional analysis. Put our 4 grains over 1. We're getting rid of grains, so I'll put it on bottom. 1 grain is 60 milligrams, so we put milligrams on top. And now the grains cancel out. 4 times 60 is 240 milligrams. On bottom, 1 times 1 is 1, so it's just 240. Okay, so enough of the background stuff. Let's get into the dosage calculations. There are 3 methods of dosage calculation. And I am going to go through them in order of my least favorite to my most favorite, just because the last method is the method that is just the most universal, most useful. So the first method is called the dosage formula. And just to define some variables, D in any of these is the doctor's order. H is what we refer to as an on-hand dose. Excuse me. And these two, the doctor's order and the on-hand dose, need to be in the same unit for this formula to work. If they're not, we have to convert the doctor's order into the on-hand, the same unit as the on-hand dose. V is what we call the vehicle. And this is simply what carries the on-hand dose into the patient. It could be a single tablet, could be a volume of a liquid, of an elixir, whatever it is that carries that amount into the patient. And finally, we have A, which is the amount to administer. So the dosage formula is simply doctor's orders divided by the on-hand dose times the vehicle equals the amount to administer. And our first example will be an order of 750 milligrams of ibuprofen. And our supply, so the label on our supply usually gives us both the on-hand dose and the vehicle. So our supply here is 300 milligram scored tablets. And I know Karen will go over this a lot more later, but when you see scored, that means you can break them in half so that you can go to a half tablet. If it's unscored or if it's a capsule, you'd have to go to the whole capsule. So anyway, the doctor's order is the 750 milligrams. Remember, we mentioned whatever is the on-hand dose has to have the same unit as the doctor's order. So it has to be milligrams. In our supply, we have 300 milligram, so that's our on-hand dose, and scored tablets. So the vehicle that carries the 300 milligrams into the patient is one tablet. So here, the milligrams cancel out. We have 750 divided by 300 is 2.5 times one tablet. 2.5 times one tablet is 2.5 tablets. So you would administer 2.5 tablets to that patient. Another example. Oops, go ahead if you had a question.
No, that was a sneeze.
Okay, no problem. So we have an order for 80 milligrams of an elixir. Our supply says that we are constituted at 16 milligrams in 5 milliliters of solution. So our doctor's order is the 80 milligrams again. Our on-hand dose comes off of the label on the supply. That's the 16 milligrams. Has to have the same units. So it has to be milligrams. And then what carries that into the patient would be 5 milliliters of the solution. So times 5 milliliters is our vehicle. So the milligrams cancel out. We have 80 divided by 16, which is 5. 5 times 5 milliliters is 25 milliliters. So you would administer 25 milliliters of that solution to the patient in order to get them the 80 milligrams of medication. So let's say we are ordered 0.3 grams. And we have a supply of 150 milligram per capsule. So being capsules, that means we have to go to the nearest capsule. We have our doctor's order of 0.3 grams. But when we go to set up our formula, we see that our supply is in milligrams, not grams. So we have to change our order. We have to convert the doctor's order into that unit of the on-hand dose. So we'll put the 0.3 grams over 1. We're going to multiply. We're going to put grams on bottom, milligrams on top. And we know from our basic standard equivalencies that 1 gram is 1,000 milligrams. So now the grams will cancel out. 0.3 times 1,000 milligrams is 300 milligrams. 1 times 1 is 1, so that's just 300 milligrams. Now we can circle back and put that into our formula. So the order was converted to 300 milligrams over the on-hand dose of 150 milligrams times it's per capsule. So that's 1 capsule would be the vehicle. So the milligrams will cancel out. That's why they had to be the same unit. 300 divided by 150 is 2 times 1 capsule gives us 2 capsules. Well, let's get a little more adventurous here. Partly because it shows some of the weaknesses of the formula. So let's look at a doctor's order for codeine GRSS. And we have a supply that's 15 milligram tablets. So the doctor's order is the GRSS. Remember, SS is 1/2. So that is 1/2 of a grain is what the doctor's ordered. Our supply, however, is listed in milligrams, so we're going to have to convert the doctor's order again. We'll put it over 1. In my conversion factor, I'll put grains on bottom, and I need to go to milligrams. 1 grain is 60 milligrams. So now the grains will cancel out. 1/2 times 60 milligrams is 30 milligrams. And 1 times 1 is 1. So the doctor's order has been converted into 30 milligrams. The on-hand dose of 15 milligrams goes under that. And it is 1 tablet is the vehicle. So the milligrams cancel out. 30 divided by 15 is 2. And 2 times 1 tablet is 2 tablets. Let's look at, we'll do one more example before I move on to the next method. And this is just to show you that we run into some units that don't necessarily fit our standard conversions, but we can still work with them anyway. So our order here is potassium chloride, 40 milliequivalents. If we look on our supply is a vial of 15 milliliters oral suspension at 12 milliequivalents per 5 milliliters. So far, we have looked at doing our dimensional analysis where we're told 1 capsule is 150 milligrams or whatever. But technically, any rate, and this is listed as a rate, can be used as an equivalency. 12 milliequivalents per 5 milliliters is just saying that 12 milliequivalents is equal to 5 milliliters. And so I can still use that as any rate can be used as a unity fraction. So I have my order of 40 milliequivalents. My on-hand dose is 12 milliequivalents. in a vehicle of 5 milliliters that carries that into the patient. So the milliequivalents cancel out. I have 40 divided by 12, which is 3 1/3, times 5 milliliters gives us 49.5. Oops, not 49.5. What do we get there? 16 2/3 milliliters. So even though you may not, and I'm sure some of you are probably way more familiar with them than I am, even though I'm not familiar with the unit of milliequivalent, it doesn't matter as long as we somewhere have a rate or an equivalency that tells us how it relates to another unit. We can do that conversion to get it out of there. So that is the dosage calculation formula. Probably my least favorite method because it requires you to plug stuff in. And it requires you in many cases, as we saw up here, you might have to do conversions to the doctor's order before you can plug it into that formula. The second method we'll talk, first of all, any questions on the dosage calculation formula?
Looks good from here.
Okay. So the second method is the proportion method. And the proportion can be set up one of several different ways. The typical way we do it looks like this. You have the on-hand dose over the vehicle because that's a typical rate you're given. Like in this last problem, 12 milliequivalents per 5 milliliters was already set up in that form. And then we have the doctor's order over the administered dose. So if I'm looking at some of the same examples I've just done, if I have an order for 750 milligrams of ibuprofen, and a supply of 300 milligrams scored tablets, so my on-hand dose is the 300 milligrams. My vehicle is one tablet, carries 300 milligrams. Now, one thing in a proportion is the units must match up in one of two directions. Either these two units have to be the same, and we can see those clearly are not, so that's not going to be the way we match up. Or these two units have to be the same. And then, of course, both of these units would have to be the same. So since this is in milligrams, this over here also will have to be milligrams. Since this is in tablets, this over here will also be tablets. So the doctor's order of 750 milligrams goes on top. And now to solve this, when we're solving a proportion, the shortcut that we use to calculate is called cross, multiply, and divide. So we look for the two numbers that are diagonal with each other. That's the one tablet and the 750 milligrams. So 1 times 750 is 750. Notice I left off the units because I already did the units when I matched up side to side. So now the number that is diagonal with our missing number is the one we divide by. So 750 divided by 30, or by 300, is 2.5. So we get 2.5 tablets. If we look at our second example, we ordered 80 milligrams of elixir. And our supply of 16 milligrams in 5 milliliters of solution. Have you guys covered, by the way, the difference between solution and suspension?
Not yet.
Not yet? So a solution is chemically embedded. You have particles of the fluid. In a solution, whatever the medication is, usually a powdered medication dissolved in it or another liquid dissolved in it. the particles of the medication are actually trapped in the gaps between the particles of the fluid. They will stay there forever. In fact, shaking a solution can be a bad thing because shaking it can cause it to temporarily separate. So that's a solution. A suspension is kind of like throwing a handful of dirt into water. You can shake it up and it gets evenly mixed, but you don't have to let it set for very long or it settles to the bottom. So suspension, you must shake it before you use it. A solution, if you do accidentally shake it, you should actually let it sit for a few seconds to reincorporate itself before you use it. So anyway, that's your little side chemistry note for the day. Back to the calculation. So we have our on-hand dose of 16 milligrams over the vehicle of 5 milliliters. Now again, on the other side, we know that this has to be milligrams. This will have to be milliliters because those units have to match up horizontally for this formula. So the 80 milligrams has to go on top, and what we get on bottom will be our amount to administer. So we cross multiply. 5 times 80 is 400. We divide by the 16, which is going to give us 20. Is that 25? Yeah, 25 milliliters. So the power of the proportion is we don't necessarily have to memorize locations. I gave locations up here for everything, but they don't have to stay in that same spot. The key is we have to match up our units in at least one direction. Milligrams and milligrams, milliliters and milliliters. If I had forgot that, and I just put out, okay, well, my doctor's order is 80 milligrams, well, now I know I either have to have milligrams here or here in my proportion. And it doesn't matter which one. If I put the 16 milligrams here, it's matched up in one direction. But there has to be a relationship in the other direction as well. The vehicle has to be linked to the on-hand dose, since they're both on the label of the supply. So since I put the 16 milligrams on bottom, I would have to put the 5 milliliters on bottom as well so that they match up, because both of these are describing the supply. And now this is going to end up being milliliters as well. I cross multiply and divide. Notice I get the exact same numbers. 80 times 5 is 400. Divided by 16 is 25. So even if you don't have that location for pieces in the proportion memorized, all you have to do is worry about matching up the units. One of the weaknesses, however, of the proportion comes similar to with the dosage formula if the doctor's order is not in the same unit as what's on the label. So for example, let's say we have an order for 0.125 milligrams of Synthroid. We look at our supply, and it says we have 50 microgram per tablet. So again, this unit is different than this unit. So I have to make that conversion. .125 milligrams over 1. I'll put milligrams on bottom here. I need to convert it into micrograms. 1 milligram is 1,000 micrograms. My milligrams will cancel out. 0.125 times 1,000 micrograms is 125 micrograms. And 1 times 1 is 1. So that's going to be 125 micrograms instead of the 0.125 milligrams. So now I'll put in my on-hand dose, 50 micrograms over the vehicle of 1 tablet. On my other side, I know it's going to be micrograms here and tablets here because my units have to match up. So 125 micrograms, it's 125. And I cross multiply and divide. 1 tablet times 125 is 125. And I divide by the 50 to get 2.5 tablets, so 2.5 tablets. So that proportion is a handy little tool for simple calculations, but you can see if our units don't match up, we have to do that conversion again, just like with the formula, before we can plug numbers into the proportion. Any questions on the proportion?
No.
Okay, perfect. So then on to the star of the show. My favorite method is dimensional analysis. And dimensional analysis is nothing more than matching up units like we did in our unit conversions and making sure things cancel out and using those equivalencies just to convert one unit to another. So if I have, well, let's go back to that first problem again. We have ordered 750 milligrams of ibuprofen and a supply of 300 milligram scored tablets. So dimensional analysis says you always start with the doctor's order and work from there. So I'm going to take my 750 milligrams and I put it over 1. I make it into a fraction, just like we did with our other units when we were trying to convert. Now, since I have milligrams here, I want to put milligrams on bottom so they cancel out. Here I have 300 milligrams per 1 scored tablet, or just 1 tablet. Again, these go together because they're describing the label on the supply. The milligrams cancel out. 750 times 1 tablet is 750 tablets. Of course, that's a nonsense unit. We have to simplify or reduce this yet. On bottom, 1 times 300 is 300. Then we divide it out. 750 divided by 300 is 2.5 tablets.
Okay.
If I have an order for 0.3 grams of Axid, and so my supply here is listed as again, capsules, 150 milligrams per capsule. So again, the dimensional analysis will always just start out with the doctor's orders, 0.3 grams. Since it's a simple unit, I just put it over 1 to make it a fraction. To do my conversions now, this is in grams, so one of the first things I'm going to do is get rid of grams. Well, right now there's nothing else that's in grams. But I find that I have something in milligrams, so if I convert from grams to milligrams, then I can continue to go on. So 1 gram is 1,000 milligrams. The grams cancel out, and now we're in milligrams. So now I can continue on. I have milligrams, and I want to get rid of those, so I'll put milligrams on bottom. And I have this equivalency telling me that 150 milligrams is equivalent to 1 capsule. So 150 milligrams equals 1 capsule. So the milligrams cancel out. On top, 0.3 times 1,000 is 300, times 1 capsule is 300 capsules. Again, that's a nonsense unit. We're never going to deal with 300 capsules. We have to reduce yet. On bottom, 1 times 150 is 150. And then we divide. 300 capsules divided by 150 is 2 capsules. So we'd administer 2 capsules to the patient. So that dimensional analysis, I mean, we're doing simple dosages like those examples we've looked at so far. All 3 of those methods seem to work just fine. The dimensional analysis, I like it because I don't have to remember any formulas. It's simply start with the doctor's order and start looking for either equivalencies or standard conversions to do conversions to convert that into what we're going to administer to the patient. So where that becomes a little more useful or a little more vital is when we get into IV flow rates. So an IV flow rate is administering a medication over time. And of course, there's all sorts of different units we can use for IV flow rates. It can be listed as milligrams per hour. Could be listed as milligrams per minute. Could be listed as milliliters per hour or milliliters per minute. Or even GTT stands for drops. So drops per minute. These last 2 are the 2 most common, but any of those is acceptable as a flow rate. So if I have a doctor's orders to administer 4,800 milliliters over 8 hours. The flow rate here, I could convert it into milliliters per hour. To do that, I would just have to divide it out. 4,800 milliliters divided by 8 hours. Well, what we're doing is we're converting into something called a unit rate. And a unit rate means the second number, whatever the first number is, the second number is 1. So it's per 1. And so the way we convert something into a unit rate is we divide by the numerical value of the second number. So the second number here is an 8. We would divide by 8. 4,800 divided by 8 is 600 milliliters. 8 hours divided by 8 is 1 hour. And once the bottom number, the second number, is simply a 1, and whatever unit is, we don't need the 1 there anymore. We would just write it as 600 milliliters per hour. So this is the full process. The shortcut is we're just going to say we're going to divide the numbers and put the units into the units for the rate. What if I wanted that not in milliliters per hour, but milliliters per minute? So if I started with my 4,800 milliliters per 8 hours, I could use my dimensional analysis to get rid of hours. Now, hours are on bottom, so to cancel it out, we have to put hours on top. And 1 hour is equivalent to 60 minutes. So now the hours will cancel out. On top, we have 4,800 milliliters times 1, which is 4,800 milliliters. On bottom, we have 8 times 60 minutes, 480 minutes. And now, again, we'll do that shortcut to divide it out. 4,800 divided by 480 is just 10. Milliliters divided by minutes is milliliters per minute. So let's look at some examples of calculating flow rates. So if I am ordered to infuse 400 milliliters, oops, also forget my zeros in there, over 8 hours. And I'm going to want this both ways. I want this in milliliters per hour. And I want to know milliliters per minute. So I simply start out with the doctor's order and I turn it into a rate. 400 milliliters over 8 hours is literally 400 milliliters over 8 hours. To put it in milliliters per hour, all I have to do is divide this out, reduce it. 400 divided by 8 is 50. Milliliters divided by hours is milliliters per hour. Or I could have, if I want milliliters per minute, have to get rid of the hours since they're on bottom. I'll put them on top. 1 hour is 60 minutes, so the hours cancel out. We have 400 milliliters times 1 is 400 milliliters. 8 times 60 minutes is 480 minutes. If we divide that out, that is what, 0.833, somewhere in there, 0.83, we'll round it to milliliters per minute. Now, of course, it doesn't stay that simple. Most of the time, it's not going to be milliliters that's ordered over a period of time. It's going to be milligrams. So if we have an order to infuse 2,400 milligrams over, we'll stick with 8 hours. And we look at the label on our supply, and our supply is telling us that that is solution constituted at 25 milligrams in every 48 milliliters. So a pretty weak solution. And let's just say we want this in milliliters per minute. So to get to milliliters per minute, I start with the doctor's order again. 2,400 milligrams over 8 hours. Now we want milliliters per minute, which means both units have to change. Milligrams are going to have to change to milliliters. Hours are going to have to change per minute. Which one we do first is just a matter of your own personal preference. I tend to like to convert time first and get it over with. So that's what I'm going to do. Hours are on bottom. I'm going to put hours on top. 1 hour is 60 minutes. So the hours have canceled out. I am now currently in milligrams per minute. So now I need to get rid of the milligrams. Since milligrams are on top, come here. I'm going to put milligrams on bottom to get them to cancel out. And my label on my supply says that 25 milligrams is equivalent to 48 milliliters of fluid, of solution. So my milligrams cancel out. And now on top I have 2,400 times 1 times 48 milliliters, which is going to give us 115,200 milliliters over 8 times 60 times 25, giving us 12,000 minutes. And then it's just a matter of dividing that out. 115,200 divided by 12,000 gives us 9.6. And of course, that's milliliters divided by minute, so milliliters per minute. Now, some of you may have noticed as you looked at this, we could have done some cross-canceling and reducing. We could have done, let's 8 and 48 both divide by 8. So we could have got 6 and 1. And of course, we could have divided the 2,400 by 60 to get 1 and 40. Yes, that's fine to do that, but I find students make a lot of mistakes when they do that. If the numbers are small enough that they can stay on the calculator display, It's generally producing fewer mistakes if you just calculate out the big numbers and divide them rather than trying to cross cancel or cross multiply like that. So let's look at an order. I'm going to do one more, and then I'm going to have you guys try one in your notes, by the way, so get yourself ready for that. So I'm going to order to infuse 2,000 milligrams in 4 hours. On a supply that is labeled 5 milligrams in 12 milliliters of solution. And we want to know, again, milliliters per minute. So I start out with my doctor's order, 2,000 milligrams over 4 hours. And again, I have to change both of those units just because it's what I'm used to. I'm going to change the time first. So I'm going to change the hours. Hours are on bottom, so I'm going to put them on top to cancel them out. 1 hour is 60 minutes. So my hours are canceled out. Now to get rid of the milligrams. Milligrams are on milligrams are on top, so I put them on bottom to cancel them out. And my supply label says 5 milligrams is equivalent to 12 milliliters. So the milligrams have canceled out. On top here, I have 2,000 times 1 times 12 milliliters, which is 24,000 milliliters. On bottom, 4 times 60 times 5, which is, I believe, 1,200 minutes. I'm going to double check myself there because it's Monday morning. It is. And so we'll do the 24,000 divided by 1,200 to get 20 milliliters per minute. Okay, so now I'm going to have you guys try one in your notes for me. The order is to infuse 1,600 milligrams over 4 hours with a label on the supply reading that is constituted as 8 milligrams in 5 milliliters of solution. So I'm going to give you a little over a minute here. Try that in your notes, and then we'll go over it. We want that in milliliters per minute. So let's take a look and see how you're doing. I realize some of you may not have totally finished, but that's fine. We'll make sure you're on the right track. So the doctor's order was for 1,600 milligrams over 4 hours. So we start with 1,600 milligrams over 4 hours. We'll adjust the time first. So since hours are on bottom, I'm going to put hours on top. 1 hour is 60 minutes. So the hours cancel out. Next, we'll get rid of the milligrams. Milligrams are on top, so we're going to put them on bottom. The supply label tells us that 8 milligrams is equivalent to 5 milliliters. So the milligrams have canceled out. On top, 1,600 times 1 times 5 milliliters is 8,000 milliliters. On bottom, 4 times 60 minutes times 8 gives us 1,920 minutes. So we go ahead and divide that out. 8,000 divided by 1,920. And we get 4.166666. We will round that to 4.17 milliliters per minute. So any questions how we got to that far? How did we got to that number? Okay, good. So then next, the next step that we would add to that is a drop factor. So a drop factor is saying how many drops of this fluid equals 1 milliliter of fluid. And this typically depends on a couple of things. The first thing it depends on is the viscosity of the fluid. A lot of people think of viscosity as simply the thickness of the fluid, and that has something to do with it. Thicker fluids do tend to be more viscous than thinner fluids, but it's also the surface cohesion or the surface tension on it. So the more viscous a fluid is, the larger the drops are, so it tends to be fewer drops to make a milliliter. The second is the size of the orifice. This could be the orifice in an eyedropper if you're using a dropper, or an orifice in your IV setup, your infuser. The bigger the orifice, of course, tends to affect the size of the drops. We're not going to deal with the viscosity in the orifice. We're going to be given the drop factor. So for this example, we might be told that for this fluid and this setup, the drop factor is 10 drops per milliliter. So 10 GTT per ml. So rather than calculating my flow rate in milliliters per minute, we would want to calculate it in drops per minute. And to do that, I would have started with the exact same number, my doctor's orders, the 1,600 milligrams over 4 hours. And I would still change the hours first because I still have to get to minutes one way or another. So put hours on top so they'll cancel out. 1 hour is 60 minutes. So I've canceled out the hours. And then I would put, again, we still have to get rid of milligrams. So since milligrams are on top, put them on bottom to cancel them out. And the order still says 5 or 8 milligrams in 5 milliliters. So the milligrams cancel. So far, this is the exact calculation we did up above. All that's changing is we have to add this extra step, which is to include the drop factor, to change it to drops per milliliter. We no longer want milliliters. We want drops. So to get rid of milliliters, I'm going to put milliliters on bottom. So this drop factor of 10 drops per milliliter is an equivalency. It's saying 10 drops is equal to 1 milliliter. So I can use that as a unity fraction, as a conversion factor. 1 milliliter is equal to 10 drops. So the milliliter cancels out. Now on top, 1,600 times 5 times 10 is going to be 80,000 drops. On bottom, 4 times 60 times 8 is still 1,920 minutes. Oops. My pen locked up on me here. Let's try that again. Minutes. And when we divide that out, we're going to end up getting 41.667. It'll be drops per minute. Now, there are rounding conventions there depending on what type of infuser you're using. And I'll let Karen go over that when you get to it. But some infusers have to be to the nearest drop. If that were the case, this would round to 42 drops per minute. Other infusers go to 2 decimal places. If that were the case, it'd be 41.67 drops per minute. Either one is just a variation in rounding. So let's look at an example where we start out with the full thing all at once. So let's say we're looking at an order to infuse 3,000 milligrams over 12 hours. With a supply label that says that this is constituted as 50 milligrams in 8 milliliters of solution. And for this mixture of our fluid and orifice, we have a drop factor of 15 drops per milliliter. So we will start with the doctor's order here. The 3,000 milligrams over 12 hours. I should mention, by the way, yes, we are going for drops per minute as our final unit here. So the doctor's order, 3,000 milligrams over 12 hours. Once again, we have to get rid of the hours, so I'm going to go ahead and put hours on top so they'll cancel. 1 hour is 60 minutes. So I've canceled out the hours. We still have to get rid of the milligrams. Milligrams are on top, so I'm going to put milligrams on bottom. So we go searching, and we see here that on the label of the supply, it tells us that 50 milligrams is equivalent to 8 milliliters. So we cancel out the milligrams. And now we use our drop factor. Getting rid of the milliliters, I'll put milliliters on bottom. And of course, that's telling us that 1 milliliter is equivalent to 15 drops. So the milliliters cancel out. So on top, we have 3,000 times 8 times 15 drops, which gives us 120,000 drops.
I think you did times 5, not times 15, Tom.
Did I?
I think so.
Yes, I did. Thank you. So we get 360,000 drops. That would make a big difference. On bottom, we have 12 times 60 times 50 gives us 36,000 minutes. And so that divides out. 360,000 divided by 36,000 is just 10, and then drops per minute. So I'm going to have you guys try one in your notes. Let's do in order to infuse 300 milligrams in 20 minutes with a supply that says we're constituted as 18 milligrams in 5 milliliters of solution, with a drop factor of 12 drops per milliliter. And we once again want this in drops per minute. So I'll give you about a minute and a half or so, then we'll go over that one. Now let's take a peek at this one then and see how you're doing. So I threw a little bit of a change up in here on this one. It's not over hours, it's over minutes. So we don't have to convert the minutes. So we start out with the doctor's orders of 300 milligrams over 20 minutes. And we don't have to convert the time this time. So we'll start right in with converting the milligrams. So put milligrams on bottom to cancel them out. Our supply label says that 18 milligrams is equivalent to 5 milliliters. So the milligrams cancel out. Now we need to get rid of the milliliters. And again, our drop factor of 12 drops per milliliter is telling us that 1 milliliter is equivalent to 12 drops. We put the milliliters on bottom so that they would again cancel out with the other milliliters. So now on top, we have 300 times 5 times 12 drops, which gives us 18,000 drops. On bottom, we have 20 minutes times 18, giving us 360 minutes. And then we just divide that out. 18,000 divided by 360 gives us 50 drops per minute. Anybody have any questions on that?
No.
Okay, good. So the other power of the dimensional analysis is if I need to reverse a calculation, we don't have to memorize a whole new formula. I mean, there are formulas out there for IV flow rates that will do these calculations, but you'd have to memorize the formulas. What if I am told that we want to calculate the time to infuse? Actually, I shouldn't even be told. I just need to find the time required to infuse. This would be like if you start a shift and there's an IV running and you want to know how long it's going to be before that bag is empty, so you know to go in and switch it or to disconnect it. So let's say that we have a setting, a bag that is an order for 2,400 milligrams. The infuser is currently infusing at 45 drops per minute. Your label on your supply says that it is constituted at 40 milligrams in 15 milliliters of solution, and you have a drop factor of 18 drops per milliliter. We are looking for a time. So we want to start out with a unit that has time in it. If I'm looking through here, I see that I have my infusing rate, 45 drops per minute. But I want my final answer to be in time, so I'd want the time on top. This is saying that 45 drops is equivalent to 1 minute of flow. So it would make sense to put 1 minute on top and my 45 drops on bottom. I want to keep the minutes because I want time. I have to get rid of the drops somehow. Well, my drop factor says that those 18 drops is equivalent to 1 milliliter. So with drops on bottom, I'll put drops on top here. 18 drops equivalent to 1 milliliter. The drops can cancel out. Well, I don't want the milliliters there either. I just want minutes. So I look at my supply and it tells me that 15 milliliters is equivalent to 40 milligrams. So I have milliliters on bottom, so I'm going to put milliliters on top. 15 milliliters and 40 milligrams. The milliliters cancel out. And now what I'm going to get here is actually going to be a conversion factor or a unity fraction. But I'm going to go ahead and just combine that with my 2,400 milligram is the size of my bag or the amount that was ordered to be infused. So I'm just going to multiply by 2,400 milligrams over 1 because I see that that'll cancel out the milligrams. So on top I have 1 minute times 18 times 15 times 2,400. Giving me 648,000 minutes. On bottom, we have 45 times 1 times 40 times 1, which is just going to give us 1,800. And we divide that out. 648,000 divided by 1,800 gives us 360 minutes. And of course, we could leave that as minutes, or we can convert it to hours. When I convert minutes to hours, I like to do long division so that I have the remainder rather than a decimal. Here, however, 60 goes into 366 times. So 360 minutes is just 6 hours. So it makes it a little bit simpler if I saw that I could flip this over and put minutes on top. But if we didn't see that, you could still just start with whatever number is a whole number. We could have just started with the 2,400, and we're eventually going to get to something useful. If I started with 2,400 milligrams, put it over 1, and then I have my 40 milligrams and 15 milliliters. So 40 milligrams, 15 milliliters. Milligrams cancel out. I have my drop factor saying that 18 drops equals 1 milliliter. So I have my 1 milliliter is 18 drops. My drops cancel out. And then I have my currently running flow rate of 45 drops per minute. So I put 45 drops on bottom, 1 minute on top. The drops cancel out. And I would end up with those exact same numbers, the 648,000 minutes over 1,800. So this is one of the beauties of dimensional analysis is you pick something and start with it, and as long as you just keep converting units, you should eventually get to something that is useful. Worst case scenario, if I did something strange, let's say I chose to start with my 4 milligrams and 15 milliliters. If you happen to start there, we'll still get to a usable result. I have to cancel out both the milligrams and the milliliters. The milligrams, I have the doctor's order, so we'll get to that. Let's do the milliliters. I have 1 milliliter equals 18 drops. Milliliters will cancel out. I have 45 drops per minute. And then we have the 2,400 milliliter or milligram order. Now milligrams are on top, so I have to put that on bottom for the milligrams to cancel out. What we'll end up with here is going to be a little awkward. So you have the 1,800 over 648,000 minutes. What we see is we want the minutes to be our unit, but it is currently on bottom of the rate, on bottom of the fraction. Well, remember we said every rate is an equivalency. It's saying that these two amounts are equal to each other. So we can flip it over and it'll still be equal. If you're moving 55 miles per hour, that's saying 55 miles is equivalent to 1 hour. Well, that's equivalent to saying 1 hour is equivalent to 55 miles. Flipping it over does not change the truth that those two amounts are equal. So I can do the same thing here. If you end up with the unit you want being on the bottom of the rate, you can just flip it over, get the 648,000 minutes over 1,800, and then divide it out to get our 360 minutes. Let's say I want to find the amount of medication to be infused. So let's say we're looking at the label on our bag. And it is saying that we have 2,500 milligrams in 9 milliliters. And we have a drop factor here of 15 drops per milliliter. We are running the chart. It says to run for 3 hours at a setting of 45 drops per minute. So again, here we have a lot of different places we could start. We're looking for an amount of volume. So we're looking, actually not a volume, we're looking for milligrams. I am actually going to go ahead and start with the time, the 3 hours. I usually prefer to start with a number that's by itself, that's not a rate. So I'm going to put 3 hours over 1. Now my only other time here is minutes, so I have to get rid of the hours. So I'll put 1 hour on bottom, that's 60 minutes. Since hours were on top, I had to put it on bottom this time to cancel it. Now I have my 45 drops in 1 minute, so I'm going to put 1 minute on bottom, 45 drops on top. Canceling out the minute. Now I'm just going to cancel out the things I've already used. I need to get rid of the drops, so I look for anything else with drops in it. And I see my drop factor of 15 drops in 1 milliliter. So the drops are gone. And then I have my label on my bag telling me 25 milligrams in every 9 milliliters. So to get rid of milliliters, I'll put the 9 milliliters on bottom, the 25 milligrams on top. Milligrams. And now the only unit I have left is milligrams, which is what I want. So on top there I have 3 times 60 times 45 times 1 times 25 gives us 202,500 milligrams. On bottom, 1 times 1 times 1 times 15 times 9 gives us 135. So we divide that out. 202,500 divided by 135, and we get 1,500 milligrams is the amount of medication that patient will be receiving. So as you can see here, even for the reverse calculations, dimensional analysis saves us for having to memorize a separate formula for time to infuse, the amount to infuse. You could actually use this to find if you didn't know what the concentration was, if you were looking at switching bags and you wanted to make sure you hang a bag with the same concentration. You don't have to memorize a separate formula. Dimensional analysis will get you to those numbers by simply matching up the units and canceling them out. All right, that's enough of my sales pitch for dimensional analysis. Does anybody have any questions?
Anyone have any questions? Looking like a no.
Okay, so I will save this recording and I will have a link to this recording sent to Karen by the end of the week, so you'll have it to review it if you want to. If there's nothing useful in here for you, then that's fine as well. I won't be offended. So you guys have a great